and b. So c squared is a squared plus b squared. That is Pythagoras. We don't need to go through that one again. The next thing we'll look at is our trig ratio. So this is Pythagoras. This theorem allows us, this only works for right angle triangles, so that's the only, just you could be caught out with that sometimes. It allows us to find any of the sides if we know two of the sides in a right angle triangle. We also have non-right angle triangle geometry, which we need to know, which we'll come to in a second. But first of all, we're going to look at the trig ratios created by a right angle triangle. So if I have this angle A here, we have, in relation today, we have this opposite side, this adjacent side, and this hypotenuse side. The hypotenuse is always opposite the right angle. There's three sides of a triangle, and it's based off which angle you are looking at. The ratios of those sides, so the lengths of those sides is a ratio as a fraction. Lengths of those sides can be turned into an angle. If we know that the opposite side is really long, but the adjacent side is really short, we can find the tan of that angle. And then if the opposite side is shorter and the adjacent side is longer, we'll find the tan of the angle, and they'll all be different answers based off. If you think about that, let's just look at that. So I'm just starting off with tan, which is unusual. Tan of A is the opposite over the adjacent. They're the lengths of the opposite side over the adjacent side. If you think about that, if you have a really long opposite side and a really short adjacent side, this angle is going to be quite big. Whereas if you have a short opposite side and a long adjacent side, that angle is going to be quite small. In fact, if you know those exact lengths, you can find the exact angle without knowing the other angles, except for a right angle. Okay, by knowing your opposite side, dividing it by your adjacent side, and that gives you the tan ratio. And you can use your calculator to find what the angle actually is, because A will then be what? The tan inverse button on our calculator. Opposite over adjacent. So they have this. So if you use this gives you a decimal, and then if you do the tan inverse person, it will turn it into a angle, which is great. We also have the sine ratio. The sine of angle A is the opposite over hypotenuse, which gives a different ratio, but it equally can find the angle using it and adjacent over hypotenuse. Okay, so we have those three. This is not new, hopefully. Okay. I'll do some examples now. So I'll do a find the side first. So let's say we have a right angle triangle. I'll put the angle over, I'll put it up here this time. Let's say that's 20 degrees. I have X here, and I know that this is 7 in length. How would I go about finding X? This would be, all right, let's look at the angle I have. I know that this side over here will be called the opposite side because it's opposite the angle. So it's relevant to what angle you were looking at. So if I'm looking at from this angle point of view, this one is opposite. If I look from this angle, this one is opposite. You've got to think about what angle you're looking from. This is the opposite. This one over here is the hypotenuse. So I think, right, which one has opposite and hypotenuse? Sine does. So I write sine of the angle, because sine of the angle is the opposite over hypotenuse. Sine of 20 degrees is the opposite, x, over the hypotenuse, 7. With a quick algebraic rearrangement, I know that was 7 times sine 20. If it's division over here, it's multiplication over here. It's equal to x. I turn to my calculator, I type those things in. I hope my calculator's in degrees. 7 sine 20, and that's 2.39. Okay, and now I know the length of side x. I could use Pythagoras' theorem to find the other side, or I could use the cosine. Up to you. Okay, so that's finding the side. If I need to find the angle, I'll do it over here. So let's say I have this right angle triangle, so the right angle is up here. I need to find this angle, let's call it B, and I'm given two sides, 10 and 6. And I want to find that angle up there. Yeah. 6.39. Someone else got 6.39? It could be in radians, your calculator. Probably your radians. Make sure your calculator's in degrees, not radians. Okay, so this one, my starting point, I will label, I'm looking for this angle B. I know that this side over here is called what? Which is that one? What would I call it? This side 6. Opposite, adjacent, hypotenuse. It's opposite. It's opposite the angle. This one, opposite, adjacent, hypotenuse. Hypotenuse, because it's across from the right angle. So opposite and hypotenuse, I will use sine again. So the sine of angle B is the opposite over the hypotenuse, 6 over 10. So how do I turn that into an angle? Well, this is where you can turn this into a decimal. How do I get my decimal value into an angle? Yes. B will be sine inverse 0.6. So if I type that in my calculator, how do I get that? I press second sine, and I get sine with that minus 1.6, and I get around 36.9 degrees. Okay? We've done that before. I'm sure that's not too new to you. Okay, some known angles that we need to know off by heart are created from two known triangles. Let's think about a triangle, a right angle triangle that is isosceles and has 45 degrees here and here. And let's say we have a length 1 and 1 here. That'd be the same length because they're isosceles. Yeah, that makes sense. What's this length of this side over here? How could I get it? It's Pythagoras' theorem, yeah, so it would be root 2. So the length of this side would be 1 squared plus 1 squared, which is 2 square rooted. So that's root 2. So what is the sine of 45 degrees based off this triangle? Sine of 45 degrees. 1 over root 2. And if I were to rationalize the denominator, that becomes root 2 over 2. So it can be written in two different ways. 1 over root 2 or root 2 over 2. What is the cosine of 45 degrees? Also 1 over root 2, the adjacent over the hypotenuse. Because the opposite and the adjacent are both 1, they're both the same. So that can be also written like this. This is one of our known angles, one of our known ratios we need to know. Does it change if the side is a different length? It shouldn't change because it's a ratio. It's saying the ratio of the opposite to the hypotenuse is root 2 to 2. So you can do a very quick experiment there. If you say, all right, let's say it's an isosceles triangle with 3 as my lengths, because it has to be the same length for it to be isosceles. What's this side over here? 3 squared plus 3 squared square rooted is 9, is root 18, is it? Yeah. Okay, so that's root 18. Okay, it's looking different. What's the sine of 45 degrees from this one? So I think opposite, so it's 3 over root 18. That doesn't look the same anymore, does it? Maybe if I simplify it. How do I split up root 18? So it'd be, that's root 18 is root 9 root 2, isn't it? So that's 3 root 2. So that's 3 over 3 root 2. Oh, what happens? The 3's cancel, and that's also 1 over root 2. So no matter what right angle triangle we create with 45 degrees, the ratio is always 1 over root 2 for sine and cosine of 45 degrees. And you can keep doing that forever, and they will keep canceling out forever. Okay, so that's one of our known angles. This is called a special triangle, one of the special triangles that form this table I'm going to draw in a second. How do we do the other one? Does anyone remember? No, I'm not doing the unit circle right now. I'll do that. I'll save that one for tomorrow. So if I have an equilateral triangle of lengths 2, what's equilateral mean again? All the angles are 60 and all sides are the same. So if I do this, okay, that's not a right angle triangle, but if I make one out of it, if I take half of it, this length would be 1, wouldn't it? This length would be 2. This angle would be 60. This angle would be 30. What would be this side? This is a right angle here, so I'll split this perfectly in two. Yeah, which is? It'd be minus, yeah. So it'd be squared, this squared, minus this squared, which is 4 minus 1, root 3. Root 3. Yes, using Pythagoras, I can find that to be root 3. Okay? And then I look at sine 30 degrees. So I got to go to the 30-degree angle. I got to go, what's my opposite? 1 over my hypotenuse, 2. 1 over 2. What's the cosine of 30 degrees? Root 3 over 2. What's the sine of 60 degrees? So we've got to look from the other side now. Sine 60 degrees. And the cosine of 60 degrees? 1 divided by 2. Notice the way that they're in opposition. Cosine and sine kind of go. Dima, what do you do? Cosine and sine, as the sine ratio gets bigger, the cosine ratio gets smaller. Because they're the same, because they're parts of the same right angle triangle. As the adjacent side gets shorter, the opposite side must get bigger. So, we take these and we have to know these off by heart. You can know them off by heart by recreating these triangles and doing that again. This would also work if I picked 3, 3, 3, 4, 4, 4. The same reason for this, it'll just cancel down. What is the known angles I need to remember? Yes, so we got 30 degrees, 45 degrees, 60 degrees, and it's good to know 90. We'll stop there. You can figure out, when we're doing the unit circle, we might add 180 and so on. Okay, so I need to know these. I need to know my ratios for sine, cosine, and tan. I've created most of them here. I have a way of remembering it. I do 1, 2, 3, 3, 2, 1. They're all over what? 2. But of course, this wasn't 3, this was root 3. And this wasn't 2, it was root 2. So we got to put in my square roots. So 1, 2, 3, 3, 2, 1. What is tan then? Tan of an angle is always the sine over cosine. The sine over cosine, always. So 1 over root 3, yes. Root 2 over 2, which is just 1. And root 3 over 1, which is root 3. So you get it from the ones above. And then we need to think about 90 degrees.
1, 0.
Yes. This one's getting bigger. This one's going 1, 2, 3. It's going closer and closer to 1. This one's decreasing, 3, 2, 1, 0. This one is going impossible, undefined. Yes, we've done that before. Why? Because if the cosine is 0, 1 divided by 0 is not allowed. Divided by 0 is not allowed.